So give me a chance to get set up here. Hello. Welcome to Istio Weekly, Episode 5. Thank you all for joining. Today, we'll be talking about security in Istio. Peter will show some of the details of configuring authentication, authorization, and encryption policy. And as always, we'll have dedicated time for Q&A after the presentation, but we'd love to have this be a conversation as much as possible in the given format. So if you have any questions or comments, please do put them in the chat, and we'll do our best to moderate as it makes sense. So, as we'd like to cover some of the highlights of things happening in the mesh world this week or recently. So, before diving into today's topic, we'll take a moment to cover some recent highlights. In May, the Biden administration issued a cybersecurity executive order mandating that federal agencies develop plans to adopt zero trust architectures according to guidelines prepared by the National Institute of Standards and Technology, NIST. NIST has authored a series of special publications, they call them SPs, that define zero trust and offer specific guidance for implementing zero trust architectures. If you want to learn more, check out NIST SP 800-207 and the SP 800-204 series, co-authored by Tetrate's own Zach Butcher. And in his blog post about offloading authentication and authorization mesh, Zach provides an overview of SP 800-204A and how a service mesh can be used to implement zero trust principles without having to build them into the application or the application stack. And Tetrate engineers Ignacy Barrera and Jimmy Song have published an article in the New Stack on NIST's new standards for zero trust authorization, Next Generation Access Control, or NGAC. In the article, they provide an overview of NGAC and compare it to role-based access control, RBAC, and attribute-based access control, ABAC, making the case for NGAC as a clear choice for modern software architectures. And finally, to round out this week's security-focused highlights, Joab Jackson, reporting for the New Stack, covers the work Tetrate has done with NIST on mesh security and zero trust, including this year's NIST conference on DevSecOps and zero trust architecture for multi-cloud environments. And on to events. Thanks, Peter. On July 6th, join Zach in U.S. Air Force special. Join Zach and U.S. Air Force Chief Software Officer Nicholas Chyan for Tetrate's first webinar in a series of zero trust security webinars. We'll be doing those monthly. Chyan is the champion of Platform One, the centralized team providing DevSecOps and software factory managed services with baked-in security to Department of Defense programs. Zach and Nick will discuss the future of zero trust adoption and what the new cybersecurity executive order means for government agencies and enterprises. Also, please join us on Thursday, July 8th for the next edition of Istio Weekly. Links to all the resources we've mentioned, all the highlights will be in the show notes, so go ahead and check those out at your convenience. And so with your, we also want to hear your comments, so please do either put your comments in the video or reach out to us on GitHub if you have any suggestions for topics to cover, any highlights that you'd like to mention as well. We'd love to hear from you. So with that, I'll pass the mic over to Peter and today's presentation.
Awesome. Thank you, Ryan. So today what we'll do is we will talk about authentication and authorization, and we'll explain the differences between the two, and I'll show you how these terms actually map to Istio resources and which Istio resources you can use to configure them. So Istio comes with a couple of custom resource definitions for configuring user and service-to-service authentication, as well as authorization policies. So in this episode, I'll try to explain what access control in Istio is and how it works, what is authentication and what is authorization, and how to use these different Istio resources and how they work together to answer the access control question, which is, can a subject perform an action on an object? Or if we try to translate this question to the Istio and Kubernetes world, it would be, can service A perform an action on service B? So the key three components from this question are the principal, the action, and the object. Principal in our case, or in Kubernetes' case, is a Kubernetes service. Action, assuming we're talking about HTTP, this can be a GET request, a POST request, delete, PUT request, and so on. And finally, object is a service as well. So how about authentication and authorization? So let's start with authentication first. Authentication, or authn, is all about the principal, or since we're talking about services, it's about service identity. When we say we are performing authentication, we are validating some sort of a credential and then ensuring that that credential is valid and can be trusted. Once the authentication succeeds, we can talk about an authenticated principal. If the credential is not valid or it cannot be trusted, we say that we have an unauthenticated principal, or we didn't even have a principal to authenticate in the first place. An example of authentication is when you're traveling, right? So whenever you travel, go out of the country, you have to present your passport or you have to present your ID to the customs officers. So they're the ones that will authenticate your passport or ID and ensure that that is valid and can be trusted. In Kubernetes, each workload that runs in Kubernetes gets assigned a unique identity. This identity is then used when the workloads communicate with each other. In Kubernetes, the identity takes the form of a Kubernetes service account. This service account is the identity that pods use and then present at runtime. Istio uses the X509 certificate from that service account, and it creates a new identity according to a spec that's called SPIFFE. SPIFFE stands for Secure Production Identity Framework for Everyone. So what SPIFFE does is it describes the following. It describes a naming convention that's universal, and it's based on a URI. Pretty much it's a path. It also describes how to take that identity and then encode it into different documents. The one we care about in this case is the X509 certificate. Now, the guarantee SPIFFE makes is that when you create a X509 certificate, fill in these specific fields in specific ways, and if you do that, then when you do the normal certificate validation, if you do one more extra step while you're validating that certificate, then you can also authenticate the identity that's inside the certificate. So SPIFFE says if you have that X509 and you handle it this specific way and you authenticate it in the standard way, and after you've done that, the authentication in the standard way, you check the subject alternate name in the certificate, then that's a valid SPIFFE identity. It is an authenticated principal. Now at runtime, we take these certificates and use them to do mutual TLS. So the Envoy proxies that run next to each workload are modified. So when they do the TLS handshake, they will do that extra bit required by SPIFFE validation, and those authenticated principals, both on the source and the destination side, will be available for policies. So now that we've created and have these identities for our workloads, we can use them at runtime to do mutual TLS. So the question here comes up, well, what is mutual TLS? Traditionally, when you do TLS, it's usually one way. So you open your browser, you go to google.com, and you'll see that lock, and you can check the certificate and all those things. However, when I did that, I didn't give Google any proof of my identity. I just made a request. So this is the one-way TLS, but this is also the place where mutual TLS is fundamentally different. So when two services try to communicate with mutual TLS, it is required that both of them provide certificates to each other. So both parties, the client and the server, they actually know who they're talking to. Now, mutual TLS is great, and you should have it turned on for all your services. However, there are scenarios where you probably have some legacy applications. They're not supporting mutual TLS yet, and there's also a timing problem. So let's suppose we want to enable mutual TLS across all of our deployments. We have a chicken and egg problem if we want to do mutual TLS, because a connection will either be mutual TLS or not. So the client's connecting to a server via mutual TLS, where the server is not accepting mutual TLS, that's not going to work. And a server that's attempting to serve mutual TLS, where the client wants a plain text communication, that's not going to work either. That means if we just want to enable mutual TLS, we'll have to redeploy the clients and servers in coordinated manner at the same time. Of course, all this is impossible. I mean, you can't do that reliably. And even if you somehow magically do that, you won't be able to repeat it. Now, Istio solved this problem because it has a graceful mode where you can opt into mutual TLS. And this graceful mode is called permissive mode. So by default, this permissive mode is enabled when you install Istio. With permissive mode enabled, if a client tries to connect to me via mutual TLS, I'll serve mutual TLS. If the client doesn't use mutual TLS, if I have a legacy client and it calls the server, the server can also respond in plain text as well. So I'm permitting the client to do mutual TLS or not. So using this mode, you can then gradually roll out mutual TLS across your whole mesh. So for your servers, you can turn on this permissive mode, and then the certificates will be provisioned. And if the client wants to do mutual TLS, it will be accepted and it'll work. Then you'll go to your client side, and you can gradually roll out mutual TLS on the client side as well. And you can do that, of course, service per service, and then gradually opt in all of your services. You can do it per one service, per namespace, and then mesh-wide if you want to. Now, once you moved all your services over, you can then remove this permissive mode, or rather removing it, you'll set it to strict mode. So strict mode says that you can only do mutual TLS. So if any client, any legacy client tries to connect, they will have to do mutual TLS and present their certificate. If they don't do that, the connection is not going to be accepted. It's not going to work. So this brings us to the first security-related resource in Istio, which is called PeerAuthentication. So this resource controls or configures the communication between the workloads. Using this, you can configure the mutual TLS mode that's used when the workloads communicate. By default, as I mentioned, the mode is set to permissive. So services that do mutual TLS can use mutual TLS, and if they do plain text, everything will still work. Also, you can control the mutual TLS mode at the mesh level. So you can configure permissive or strict mode across the whole of your mesh, or you can do it on the namespace level, or you can go even more granular and then use labels to set mutual TLS only for specific workloads. Now, if that's not enough, you can also control mutual TLS mode for specific ports. For example, you could set up a strict mutual TLS mode for some workloads, but then disable mutual TLS for communication only on specific ports, on specific port. So here's a couple of examples. This example sets the strict MTLS mode for all workloads that are in the namespace called foo. So the kind of the resource is PeerAuthentication. We have the name, which is default, the namespace, and then under spec, under MTLS key, we have the mode that sets the mode to strict. This is a similar one, but over here we are setting the strict mode only to the workloads that match that specific selector. So only the workloads that have app prod label set. Finally, the port level, this is where you can set the strict mode, for example, for all of your workloads in the foo namespace, and then disable mutual TLS only for port 5000. So this was all about services, right? How services communicate. But I haven't mentioned anything about users. So how do you authenticate users in Istio? So entering request authentication resource. So this resource is used for end user authentication, and it verifies the credentials that are attached to the request. This request level authentication is done with the JSON Web Token validation, so JWT token. So just like we used the SPIFFE identity to authenticate the services, we can use JWT tokens to authenticate users. So let's explain this with this sample resource. So this resource in the slide applies to all workloads in the default namespace that have the label app HTTP bin set. So any request that's made to these workloads will need a JWT token on the request in the header. So the request authentication resource configures how the token and how the signature is authenticated using the provided key set. So that's the JWKS URI field. That's where you can point to the public keys that can be used to authenticate the token and the signature. Now, if the request to this specific HTTP bin workload does not contain a valid JWT token, the token is not going to conform to those rules, the request will be rejected. On the other hand, if we do not provide a token at all, the request will not be rejected, it just won't be authenticated. So let's assume we have authenticated the request, and once we have that, then we can talk about the second part of that first original access control question, which is performing an action on an object. And this is what authorization is all about. So authorization is answering the access control portion of that question. Is an authenticated principal allowed to perform an action on an object? Or can user A send a GET request to, let's say, a specific path on service B? Now, note that the principal could be authenticated. However, it might not be allowed to perform an action. A real-world example here, your company ID card might be valid and authentic. However, you won't be able to use it to enter offices of a different company, right? Even though you have a valid ID. Or if we continue with the customs officer metaphor from before, we could say that authorization is similar to a visa stamp in your passport. So this brings us to the next point. Having authentication without authorization, and of course vice versa, doesn't help us much. For proper access control, we need both. So let me give you an example. If we only authenticate the principals and we don't authorize them, they can do whatever they want and they can perform any actions on any objects. The other way around, if we authorize a request, but we don't authenticate it, then we can pretend to be someone else. And again, we can pretend to be admin and then do any actions on any objects just like we did before. Now that we're armed with an authenticated principal, we can now decide how to restrict access or control access based on that. Yes, you've guessed it right. There is another resource called authorization policy. So this is the resource where we can make use of the principal from the peer authentication policies and from the request authentication policy. So remember, there are principal when the services communicate, but there's also a principal when you do request authentication. Now, if we are trying to write policies based on the peer or service identities, there's a field called principals that we can use. And if we're making decisions based on the request authentication or the users, we can use the request principals. So let's look at an example. So this example applies the authorization policy to all workloads that have that app prod label set. The second part of the resource is where we are defining the rules and saying that we are allowing calls from a source that has any request principal set. That's that star here, right? So it doesn't matter. We're not being very specific. We just want the request to have a principal set. With this authorization policy and the request authentication policy that I showed before, we are guaranteeing that only authenticated requests will reach that those workloads with the app prod labels set. So let's break down the different cases that could happen. So let's say if the token is not present in the request, it will mean that the request is not authenticated. And this is what the request authentication resource will do. And because of that, there won't be any request principals set. However, since we are requiring any request principal to be set in the authorization policy, however, there isn't one, it just means that the request will be denied. The second case is if we provide an invalid JOT token. In this case, the request authentication will take care of the validation, and since the token is invalid, the validation will fail, and the request won't even reach the authorization policy state. Finally, the happy pad, if we have a valid token and we provide a valid token, the authentication will succeed, which will then set the request principals field. And since we are only allowing calls from sources with the request principal set, the request will reach the workload. So the previous example was a fairly simple one, but there are multiple ways that you can write more complex rules in the authorization policies. Now, we've seen the from field in the previous example. So with the from field, you can define a list of source identities, source namespaces, and principals that are allowed to call the services that the policy applies to. This example will allow calls from the services that use the workload service account, so that's under source principals, and are also coming from the prod namespace and have the request principal set to tetrade.io/PeterJ. The second field is called the to field, and this is where you can specify what paths and what operations and methods can be used when making the calls to the service. This example shows that we can call /logs and use the delete method, and we can also call get on /data path. Finally, the when field, this one allows us to specify different conditions based on the attributes from the request itself. So things like headers or values from authenticated principals. So this example shows that we can only make calls from and to when that request has a valid JOT token that was issued by accounts.google.com. So you can put all of these three things together to come up with more complex authorization policies. All right, so Orion has a question. There's a question? Yes, go ahead.
Yeah, so in the when field, can you do things like time-based rules? So like, for example, if you're, a bank teller has access to an accounts only between 9 to 5 business days. Can you do things like that in this case?
I'm not sure. I mean, the way that you could do it is you could issue tokens that are only valid between those times. But one thing that you could do is you could probably, since you can inspect the different claims in the JOT token, right? If you can inspect those claims, you can have a specific claims that either sets a role for that user or that principal, right? Or you set some field or something, and then you can inspect that when you're doing the authorization. So in a way, yes, you could. It's fully configurable, pretty much. But you'll have to use the claims, right? You'll have to create your own claims, add it to the JOT token, then you can extract it in the authorization policy. All right.
Thank you.
Okay, so we were recapping the big three things that we talked about. First was the services and their identity. So the services get the identity through X509 certificates, Kubernetes world. This is service accounts. The PeerAuthentication resource is the one that controls the type of the communication between the services. So this is where you can set mutual TLS mode, either to permissive or strict. So when the services are authenticated, then the certain metadata about the service is stored, and you can use that metadata later to enforce access control. So stuff like principal names, for example. Second thing was were the users. So to authenticate users with JOT tokens, you can use the RequestAuthentication resource. And just like before, once the users are authenticated, the information that's baked into the JOT token can then be used to perform access controls. And this is the JOT token can have, it has the default fields, but as I said, you can add your own claims to it and then keep key value pairs pretty much, and then do some checks and enforce rules based on that. Finally, once you have the authenticated principal, be it either the service or the user, you can then use the authorization policy to create different rules that can specify which services can call the workloads, which paths and methods can be used, as well as under what conditions. All right, I think I've talked enough, and you've seen a lot of slides. So let's go through a quick demo. So in this demo, I'll have two workloads that are running inside the cluster. One is called front end, and the other one is called customers. Front end is just a simple website that makes a request to the customer service, and then it displays the response on the website. Now, additionally, the front end will allow us to authenticate using Auth0 service. So we can click, we'll be able to click the login button. We'll be taken to the Auth0 login page to authenticate. From there, we'll get the JOT token, and then we're taken back to the front-end website. Then, when the front-end makes a request to the customer service, it will attach that token, the authorization token, to the request. So we'll see how this works without any policies applied, and then how it works when we actually apply the policy, and if we're logged in or if we're logged out, to see that we don't actually get anything back from the service if we're not authenticated. All right, so let me switch to this screen here. And of course, this timed out while I was talking. It's all good. Okay. Just need to do this to get the latest one. And then, okay, so I'll set a couple of secrets that I need to set, and then I'll deploy. Let me just do the secrets thing first. I'm just setting some environment variables here. There you go. Okay, and I'm back. And then I'll create the secrets that will be used by the front-end app. So front-end app, sorry. So the first one will be a secret that holds the client ID and the actual secret string. And this is all coming from the Auth0 website. So in the Auth0, I've actually created an application called Istio Weekly Demo. It has a name, it has a domain, it has a client ID and the secret. So those are the first thing that I've set and created as secrets here. So the next thing is I will create a config map. So config map will hold the issuer base URL, which is just the base URL to our auth0 domain. Audience, let me show you the audience as well. With web front end demo, again, this value is coming from auth0 from the API. I've created the web front API here. This is the actual audience identifier. And then finally, I'm also exporting a base URL. This is the URL or the IP address of my ingress gateway. So they should match. And this is the same thing that I've set in the application here, because auth0 needs to know like what are the valid application callback URLs and logout URLs. So it can do a callback once it authenticates the user, right? Note that this was very lazy from me, just using the IP. Here you would probably use your actual domain name. You would use HTTPS and all those things, of course. Okay, so I have these two. I have the secret and I have the config map created. So the next thing that I'll do, I will create the deployment. And this will create that front end, web front end container or pod, and the customer's pod as well. So we'll wait for this to start. Okay, so these two are running. Next thing that I need to do, of course, I need to configure the gateway, the ingress gateway. Let's do that. Just allowing everything in. And then in order to expose the web front end, we also need to create a virtual service. For all the hosts, attaching the gateway to it and just setting the destination to the service inside the cluster. Okay, so let's do that. And then we can look at the website right now. So just copy this URL. Paste the URL here. And you'll notice that this is our simple front-end, web front-end website. And this is the response from the customers. Now, since we're not enforcing anything, we don't have any request authentication, we don't have any authorization policy, front-end can make calls to the customer service and get the response back, right? So let's change that, right? So the first thing that we'll do is I will create the request authentication resource that will apply to the customer's pod. And in here, I'm setting the JOT rules, I'm setting the issuer, and these are all the values that you got from auth0, right? So if you go to auth0, you create an application, these are all things coming from there. This keys URL, this is actually public. These are the keys that are used to validate the requests, right? The token. And then this is the issuer that set the URL you get when you sign up for auth0. So let's do this one. So we have this request authentication resource created. So what this means is this will just validate that that we have a token or if we don't have a token. So if I refresh this page, we can still make calls, right? Because even though we haven't provided any tokens to it, which means that we haven't actually done anything, right? We need an authorization policy that will actually require the callers to have that request principal set. So regardless if our token is valid or if it's not valid, we can still call, right? Because we're only checking that we're not actually checking that the principal is set. So let's create that authorization policy now, and it'll be extremely simple. So we're applying this authorization policy to the customers as well. And then we're saying, explicitly calling out to allow the calls from any source that has any request principal set, right? Let's do this one, and let's see what happens now. So this is deployed. If I go back to my web front end with simple login page, and I refresh a couple of times. Come on, please work. Live demo. Oh, I'm actually logged in. That's why it works. Let me log out. There you go. So it was working the way it was supposed to work. So I'm logged out. right? Meaning I don't have any tokens. I'm not enforcing it. I don't have the tokens. The authorization policy checks that there's no request principal set. It checks if there's a request principal set. There isn't one, and I get back a 403, right? Now, if I go and actually log in, and I'll just use my dummy account here. This time, I can actually get the response back from the customers. And if I check my profile, this is the data from the profile that you can create. Like you can use Auth0 to create, like manage your users there as well. I could even log in with a different username. Let me use this one. Oh, I actually don't have it. If anyone wants to try, they can actually go and sign up. And they'll be able to see the responses there as well. So let me log in again. This was just a dummy account that I created. There you go. I get this back. All right, so that's for my demo. I hope this was useful, and I'm glad. Like I felt like the demo didn't work, but then it was all fake and it actually worked. So awesome. That's all from me, Ryan.
So, Peter, yeah, I have a couple of things to that struck me watching it. Now, you integrated Auth0 and MTLS without any changes to the front end and the customer service, right? Like they don't know that's going on. That's all happening outside, right?
Exactly. I mean, the only thing, one thing that there are changes to the front end, of course, right? Like I had to implement the login functionality so it gets redirected to Auth0's website. I mean, but that you would have to do that anyway, right? If you're gonna do this functionality. But then other than that, right? This is just what we're doing here is we're just modifying the Envoy proxies, right? To do all these checks and all these validations. Yeah, so the applications themselves, they don't know anything, right? They have no idea. Like the customer service has no idea that someone needs to have a JOT token in order to call it, right? It's just application doing whatever it's supposed to be doing, and the configuration of that is separated from the application and the business logic, right? So if at some point you decide that, well, now we need this specific principle in order to call that specific method on the customers, you can just switch the configuration and without even touching the application, right?
So that has, to me, that seems to have pretty significant implications for developer productivity as well as security policy authoring and enforcement. Like you can develop your app without having to build in the authentication and authorization capabilities, and those become somewhat orthogonal to the application itself as a sort of cross-cutting concern. And so as an app team, you're not saddled with the responsibility of building that in. And from a security team perspective, you are empowered to set policy, like what's the MTLS policy? Is it permissive? Is it strict? What are the authorization rules between services and stuff? You can do that without having to synchronize those policies with the application development team, and you don't have to wait until a release goes out to change policy, right?
Exactly.
So to me, that seems like a really big win.
It is. I mean, if you think about if you're a developer, right? You're like, I'm not saying developers should not think about security. They sure have to think about all that, right? But I mean, I personally would delegate that to the security team and like someone who's way more into that world and understands that better and has the big picture of all the services, not just one service, right? But yeah, as a developer, be focused on your business logic, right? Sure, think about security and all that, of course, but then it's kind of you don't have to bake anything into your application, right? You don't have to do any certificates, MTLS, thinking about that, how I'm gonna handle this in the application. That's all decoupled. The configuration, the operators, whoever's managing that portion, right? They can be the ones to create the configuration and configure everything, right? You just focus on your APIs, focus on your business logic, and everything else can be done from the, I guess, security team level or operator level.
Right. And also, like your security posture isn't dependent on the quality of a particular implementation of MTLS, for example, in a particular technology stack. Like, for example, I know we've done work where by taking the MTLS implementation out of Java and into the mesh, you've seen huge performance increases because the Java implementation of MTLS happens to be a lot more resource intensive than the one in Envoy. So like that's also a big win of standardizing across whatever the application stacks happen to be. You can standardize the implementation of your security and policy controls, right?
Exactly. Yeah. It doesn't. Istio doesn't care if you're writing Go, if you're writing Java, C Sharp, whatever you do. It doesn't really
Right.
matter what your application is. It's Envoy that's brokering all this communication, doing all this hard lifting, doing the MTLS if needed, right? Doing the certificates, auth policies, all like enforcing RBAC, all those things. That's what Envoy is doing, right? Envoy is the brains, I guess, behind all this. And we, as end users or operators, we control all those different levers through these high level resources from Istio. Right?
Awesome. Well, thanks, Peter. That was extremely helpful, at least for me. So thank you very much for putting together the presentation. We hope you all found it useful as well. And we also hope you join us in 2 weeks on July 8th for our next episode where we'll talk about Envoy fundamentals. You can find the Istio Weekly schedule and all about the Tetrate Istio district and community at istio.tetratelabs.io. We put together all the tutorial material up on GitHub at github.io/tetratelabs.io/Istio Weekly. Again, links will all be in the show notes. And chat with us on the Get Istio channel and the Istio Slack workspace, slack.istio.io, or leave a comment on this video. We look forward to seeing you next time when we cover an intro to Envoy fundamentals.
Thank you. Thanks, everyone. Bye.